This is SpaceTime, Series 21, Episode 25, coming up on SpaceTime. The alien asteroid that likely came from a binary system. New details on a stellar system that passed through our own solar system. And using data from 3 satellites to help scientists model the Sun's coronal mass ejections. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
New research suggests that Oumuamua, the rocky object identified as the first confirmed interstellar asteroid, very likely came from a binary star system. A binary star system is one with 2 stars orbiting each other. In fact, most star systems contain multiple stars. Our Sun, therefore, is unusual in only being a single star system. The study's lead author, Dr. Alan Jackson from the University of Toronto, says it's really odd that the first interstellar visitor which astronomers identify is an asteroid. That's because comets would be a lot easier to spot, and star systems eject far more comets than they do asteroids. Jackson and colleagues were interested in finding out how efficiently binary systems are at ejecting objects. The authors found that rocky objects like Oumuamua are far more likely to come from binary rather than single star systems. They were also able to determine that the number of rocky objects being ejected from binary systems would be comparable in numbers to icy objects. Once they determined that binary systems are very efficient at ejecting rocky objects, and that a sufficient number of them exist, they were satisfied that Oumuamua very likely came from a binary system. They also concluded that it probably came from a system with a relatively hot high-mass star, since such a system would have a greater number of rocky objects closer in. Their findings have been reported in the monthly notices of the Royal Astronomical Society. The authors suggest that this asteroid was most likely ejected from its binary stellar system sometime during the formation of the system's planets. Oumuamua, which is Hawaiian for Scout, was first spotted on October the 19th, 2017. With a radius of 200 metres and travelling at a blistering 30 kilometres per second, at its closest point, Oumuamua was just 33 million kilometres from the Earth. When it was first discovered, astronomers initially assumed the object was a comet, one of countless icy objects that release gas when they warm up on approach to the Sun. The problem is it didn't show any of this comet-like activity as it got closer and closer to the Sun, and so it was quickly reclassified as an asteroid. Researchers were also fairly sure that it came from outside our solar system based on its trajectory and speed. An eccentricity of 1.2, which classifies its path as an open-ended hyperbolic orbit and such a high speed, meant, unlike solar system objects, this body wasn't bound by the gravity of the Sun. You're listening to SpaceTime. I'm Stuart Gary. A new study has confirmed that an alien binary star system which passed through our solar system 70,000 years ago would have affected the orbits of many distant comets, sending at least some of them towards the inner solar system and the Earth. The stellar flyby, the closest ever documented, happened just as Homo sapiens were leaving Africa, and the Toba supervolcano on the island of Sumatra was undergoing the largest volcanic eruption in human history. Hominids living at high latitudes, including Neanderthals, the Novitians and Homo erectus, would have noticed an unusually bright red star in the night sky, visible for several years. The findings, reported in the monthly notices of the Royal Astronomical Society and on the pre-press physics website archive.org, are based on a study of 340 objects in the Oort cloud, a region of comets, icy worlds and debris surrounding the solar system and extending deep into interstellar space. The research by Carlos Ariel de la Fuente Marcos from the Complutense University in Madrid, together with Xavier Araceth from the University of Cambridge, concluded that the trajectories of some of these distant worlds would have been gravitationally perturbed by the passage of the alien star system. The stellar system, known as Schulze's star, named after the German astronomer who discovered it, is now some 20 light-years away. But 70,000 years ago, it would have passed some 52,000 astronomical units, or 0.82 light-years from the Sun. An astronomical unit is the average distance between the Sun and the Earth, about 150 million kilometres, or 8.3 light-minutes. A light year is about 10 trillion kilometres, the distance a photon can travel in an Earth year at 300,000 kilometres per second, the speed of light in a vacuum and the ultimate speed limit of the universe. The Schulze star system is made up of two stars. There's a spectral type M red dwarf star, about 0.15 times the mass of the Sun, that's about 86 times the mass of Jupiter. And then there's a failed star known as a brown dwarf, which has about 67 Jovian masses. The two stars orbit each other in a close binary system at a distance of 120 million kilometres every 4 Earth years. Carlos de la Fuente Marcos says the team used numerical simulations to calculate the radiance or positions in the sky from which all 340 of these hyperbolic objects seem to originate. Now, in principle, one would expect these positions to be fairly evenly distributed across the sky, especially if these objects all came from the Oort cloud. However, instead, the authors found a pronounced overdensity projected in the direction of the constellation Gemini, which would fit very closely to the encounter with Schulze star. The simulations also suggest that Schulze star may have approached even more closely than the 0.6 light years indicated in earlier studies as a possible lower limit. Needless to say, the close flyby didn't disturb all hyperbolic objects of the solar system, only those that were closest to it at the time. The team also determined that comets perturbed from the Oort cloud would require roughly 2 million years to get to the inner solar system. I'm Stiuart Gary. This is SpaceTime. Okay, let's take a break from our show for a quick word from our sponsor, The Great Courses Plus. Like you, I'm always pushing the boundaries of what I know, trying to learn as much as possible. And one of my favourite ways of doing this is with The Great Courses Plus. I love it, and I know you'll love it too. Get unlimited access to learn from engaging professors and experts about everything that interests you. Science, history, music, art, whatever. Learn a new language. Or how about taking better photos? It's up to you. There are over 9,000 lectures to explore. And you can stream the audio through the Great Courses Plus app, just like you do with a podcast, and toggle back to the video at any time. This week, I've been listening to Experiencing Hubble, Understanding the Great Images of the Universe. It's presented by David Meyer from Northwestern University. It's an amazingly rich visual exploration of the scientific stories behind 10 of the most fascinating Hubble images of all time. I especially like the way Meyer arranged the series to start out with our most nearest neighbours and then expand out to the most distant galaxies visible on the Hubble Deep Field. Each photo is analysed and dissected, and its importance is then discussed. Or if you prefer, just sit back and take a look at these beautiful images. It's up to you. By the way, while you're there, check out the stunning image of the Sombrero Galaxy. If you look carefully, even though it's almost side on, you'll see amazing dust lanes in between the stars. Now, I know you're going to get heaps more out of the Great Courses Plus, so I've arranged this fantastic limited time offer. You'll get a free month of unlimited access to enjoy all of the Great Courses Plus lectures. But to get the special offer, you'll need to use our special URL. It's thegreatcoursesplus.com/space. So sign up today. Go to thegreatcoursesplus.com/space. That's thegreatcoursesplus.com/space. And of course, I'll put that link in the show notes. And now, it's back to our show. Scientists have combined data from 3 satellites observing the Sun to develop new models of violent stellar explosions known as coronal mass ejections, or CMEs. The study, using NASA's twin Solar Terrestrial Observatory or STEREO spacecraft and the joint NASA and European Space Agency Solar and Heliospheric Observatory SOHO spacecraft, examined how shocks associated with coronal mass ejections propagate from the Sun. In much the same way as ships form bow waves as they move through water, coronal mass ejections set off interplanetary shocks as they erupt from the Sun at extreme speeds, propelling a wave of high-energy particles. When these ionized particles slam into Earth's magnetosphere, they can trigger geomagnetic storms or space weather events, which can damage or destroy satellites, affect terrestrial power grids, black out communications and navigation systems, and endanger astronauts in space. Understanding a shock's structure and how it develops and accelerates is therefore key to predicting how it might disrupt near-Earth space. But without a vast array of sensors scattered through space, these things are impossible to measure directly. So instead, scientists rely on models using satellite observations of coronal mass ejections to simulate the ensuing shock's behaviour. Scientists studied SOHO and stereo observations from two different coronal mass ejection eruptions, one during March 2011, the other in February 2014. The authors then tested the coronal mass ejection data with their models. One called the Croissant model because of the shape of the nascent shocks, and the other the ellipsoid model because of the shape of the expanding shocks. The findings, reported in the Journal of Space Weather and Space Climate, allowed scientists to uncover the three-dimensional structure and trajectory of each coronal mass ejection and shock. Each spacecraft's observations alone weren't sufficient to model the shocks. But with three sets of eyes on the eruption, and each of them spaced fairly evenly around the Sun, scientists could use their models to recreate a three-dimensional view. Their work reconfirmed long-held theoretical predictions of a strong shock near the front of the coronal mass ejection's nose and a weaker shock at the sides. In time, the shocks travel away from the Sun, and thanks to the three-dimensional information, scientists could reconstruct their journey through space. The modelling helped scientists deduce important pieces of information for space weather forecasting. In this case, for the first time, the density of the plasma around the shock, in addition to the speed and strength of the energised particles. These factors are key to assessing the danger coronal mass ejections present to astronauts and spacecraft. Three new Expedition 55 crew members have docked with the International Space Station 2 days after launching aboard their Soyuz MS-08 spacecraft from the Baikonur Cosmodrome in the Central Asian Republic of Kazakhstan. The mission, which was originally slated for January, was the first manned space launch for 2018 and the 63rd for the Soyuz FG version of the famous Soviet Union-era R-7 rocket.
The vehicle now on internal power. First umbilical separating away. Pretty soon we'll have auto sequence start. At this point, the ground propellant feed, so all the fuel flow into the rocket, has cut off. The engine starting to fire, ramping up. Second umbilical tower already separated. 80% and liftoff. Drew Foysel, Oleg Artemyev, and Ricky Arnold taking off on their way to the International Space Station. Those first stage engines as they light up the night sky. That first stage delivering over 930,000 pounds of thrust. 20 seconds so far since liftoff, getting good calls that the stages are performing nominally or normally. Looking very bright here on camera. I can tell you when you see these at night, it's like looking at the sun. It almost hurts your eyes, but you can't tear your eyes away from it. Soyuz rocket doing its job. All of the parameters or the data points for its trajectory looking good, continuing to rocket across the night sky. The vehicle already traveling at over 1,100 miles per hour.
90 seconds into flight.
So again, this first stage going to continue firing until just before the 2-minute mark. First, we'll hear the escape tower being jettisoned, and then following that, those strap-on boosters, those 4 liquid-fueled boosters on the first stage will be jettisoned. And getting confirmation from the visiting vehicle officer here in Houston, good first stage separation, and the escape tower has been jettisoned. It drops away at an altitude of about 28 statute miles. The Soyuz traveling at over 3,300 miles an hour. What's it like inside that capsule right now?
You get some good G-forces. You know, first stage was good. Right there with the launch shroud jettison, that's a very dynamic event. You can see out the windows, and you got thrust behind you. You're pushed back in your seat, and that makes you smile.
Launch shroud jettison. 180 seconds into flight.
Everything's still looking great for the rocket. Over 48 miles in altitude already, traveling at a speed of about 4,700 miles per hour.
Dan, everybody's always asking what it feels like inside when you launch. And first stage goes up to 4G, and then when first stage cuts out, there's that huge vertical drop-off. And then second stage builds up as the fuel weight reduces, and then there's another vertical drop-off. And now they're painting a new line on third stage, so they're not even at 2 times Earth's gravity right now, so they're just gently being pushed back in their seat, just enough to know that that engine is running.
Those are pretty quick drop-offs.
They're instantaneous drop-offs, so you definitely feel those. Those are very dynamic phases of the ascent.
All right, well, still getting good calls, normal performance of this third stage engine. We're about 7.5 minutes into the flight, velocity approaching 13,500 miles an hour.
Copy.
Again, once that third stage is done with its job, the Soyuz will separate, and then they'll execute a series of commands, all pre-programmed in, to prepare the Soyuz to fly around in outer space. and those will allow all the onboard computers to deploy the solar arrays and also a bunch of antennas.
Nominal on board, and the crew mood is festive. Prior to third stage separation, copy. 500 seconds into flight, everything is nominal. 520 seconds into flight, please be prepared for GECA 3 command. We are ready.
Welcome to low Earth orbit.
Congratulations with the successful launch and insertion into orbit. Have an excellent flight. Good luck.
And we have confirmation the third stage has shut down and separated.
Bye-bye, Moscow.
And getting confirmation from the visiting vehicle officer, all solar arrays and antennas have been deployed. So a healthy Soyuz spacecraft now in orbit. 3 crew members, Drew Feustel, Ricky Arnold, and Oleg Artemyev, ready to chase down the International Space Station. So their first taste of microgravity has got to be a feeling of relief, accomplishment, excitement, wonder. I can't imagine what's going through your head when you're in that moment right there.
I think you nailed it, Dan. Relief and extreme excitement. And then you see the crew, they're not taking any time to look outside right now, Dan. They're making sure their vehicle is safe to continue the mission. They're checking the pressurization systems. They were just closing some oxygen valves, and they're going to go through about a 30-minute process now of making sure that they are not leaking any of that precious atmosphere out into the vacuum of space. So this is actually a very busy time for the crew. Oleg and Drew there are kind of working in concert at the same time to make sure all of their systems look great.
All right, well, since it's a 2-day flight for them, so with the 6-hour flight, do you get a chance to kind of relax and get out of your suit, or are you in that seat the entire time?
I never left that seat. Your commander gets out of the seat for just a few seconds, but the left and right seaters there, in this case it'd be Drew and Ricky, they wouldn't leave their seat. But in this 2-day profile, once they check their vehicle and everything looks good, they'll do a few orbital adjustment burns today, and then they actually have a chance to go to sleep up there.
All right, well, control and monitoring of the vehicle going to be overseen from the Russian Mission Control Center just outside of Moscow, relaying all the data over to us here in Mission Control Houston.
The Soyuz MS-08 capsule was docked with the Poist module on the Russian side of the International Space Station as the 2 spacecraft were flying 408 kilometers above Serbia. The orbiting outpost had been boosted to a slightly higher orbit in preparation for the rendezvous. To achieve this, mission managers had conducted a 1-minute 48-second burn of the main engine aboard a docked Progress cargo ship in order to increase the station's altitude. The new Expedition 55 crew joined the 3 existing Expedition 54 crew members on station. Over the next few weeks, they'll carry out at least 1 spacewalk, installing new wireless antennas on the Tranquility module and replacing cameras on the Port 1 truss structure. In early April, the crew will welcome the arrival of another SpaceX Dragon cargo ship carrying several tons of fresh supplies and equipment. Meanwhile, the current Expedition 54 crew on station are slated to return to Earth aboard their Soyuz MS-07 capsule in June, and a new Progress cargo ship is expected to dock in July, as is the Soyuz MS-09 capsule carrying the Expedition 56 crew. Certainly a busy couple of months on station. You're listening to SpaceTime. I'm Stuart Gary. China has conducted its 8th orbital launch for the year, sending an Earth observation satellite into space. The mission aboard a Long March 2D rocket took off from the Jiuquan Satellite Launch Center in the Gobi Desert. This was the 4th LKW satellite in Beijing's Land Survey constellation, which are being described by China as remote sensing spacecraft. However, Western observers believe they're actually a new generation of high-resolution optical and radar reconnaissance spy satellites. And that theory gains strength when you realise how quickly this constellation's been launched. The first 2 satellites were launched just weeks apart in December and placed into identical orbits exactly 180 degrees apart. The 3rd satellite followed just a few weeks later in January, and this week's 4th launch has seen the latest LKW satellite orbiting exactly 180 degrees behind the 3rd satellite in a 488 by 504 kilometre high orbit. And the speed of their deployment reflects the importance of these satellites to the Chinese military. I'm Stuart Gary. You're listening to Space Time. Japan has successfully modified an SS-520 sounding rocket to launch a satellite into orbit. The experimental mission by JAXA, the Japan Aerospace Exploration Agency, blasted off from the Uchinura Space Center south of Tokyo. The 9.5 metre long, 52 centimetre diameter SS525 has become the smallest rocket yet to successfully place a satellite into orbit. The launch payload was the 3 kilogram Tricom 1R science CubeSat. The mission's success follows last year's failure of the SS524 sounding rocket. It lost contact with mission managers 20 seconds into the flight due to what's now believed to have been a power supply problem. The SS520 is a 2-stage solid-fuel sounding rocket, capable of carrying up to 140 kilograms of scientific research equipment on ballistic suborbital trajectories to altitudes of 800 kilometers, giving them a few minutes of space exposure before falling back to Earth. In order to achieve speeds fast enough to reach orbit, a 3rd stage, also using solid fuel, was added to the launch vehicle. The Tricom 1R spacecraft was released after 7 minutes of flight into an orbital altitude of 191 by 2010 kilometres. This is Space Time. I'm Stuart Gary. And time now to take another brief look at some of the other stories making news in science this week with a science report. A new diabetes drug may help people with obesity lose weight. The compound semaglutide mimics a naturally occurring protein that regulates appetite. The compound has a chemical structure very similar to the hormone GLP-1, which regulates both insulin secretion and appetite. In December, the United States Food and Drug Administration approved a semaglutide injection as a once-a-week adjunct to diet and exercise to improve glycemic control in adults with type 2 diabetes. The new randomized study, led by Patrick O'Neill from the Medical University of South Carolina, focused on weight loss induced with semaglutide in people with obesity but without diabetes. It found the highest weight reductions yet seen for any pharmaceutical intervention. The study included 957 participants, 35% of whom were male. All the participants had a body mass index of at least 30 but did not have diabetes. They were randomly assigned to 7 different groups. 5 groups received different doses of semaglutide. These were given through once-daily injections. A 6th group received a placebo, and a 7th group received 3 milligrams of another diabetes drug, retatrutide. All participants received monthly diet and exercise counselling. After a year, all participants receiving semaglutide had lost significantly more weight than those receiving the placebo. And the higher the dose participants received, the greater their average weight loss. Those who received 0.05 milligrams of semaglutide daily lost an average of 6.0% of their body weight. The 0.1 milligram group lost an average of 8.6%, the 0.3 milligram group an average of 11.2%, and those receiving a daily dose of 4 milligrams lost an average of 13.8%. Those receiving irregulitide lost an average of 7.8% of their body weight, while those in the placebo group only lost 2.3% on average. Warmer Arctic weather caused by climate change may be driving extreme winter weather across the United States. The findings, reported in the journal Nature Communications, examined weather data from 1950 to 2016 and found the effect was most pronounced in the eastern US, where unexpectedly high Arctic temperatures make extreme weather 2 to 3 times more likely. Scientists found that warm temperatures in the Arctic were causing the jet stream to undergo wild swings, and when it swings further south, that causes the cold air to reach further south. Since 1990, these cold episodes have been happening with increasing frequency in the eastern US, like the famed polar vortex of 2014, while at the same time, cold snaps have lessened in the west. The research is timely given the extreme winter of 2017-18, including record warm Arctic conditions and low sea ice, record-breaking polar vortex disruptions, record-breaking cold and disruptive snowfalls in the United States, and of course Europe's so-called beast from the east. 5 of the past 6 winters have brought persistent cold to the eastern United States and warm, dry conditions to the west, while at the same time the Arctic has been off the charts warm. A new study says the amount of plastic in the Great Pacific Garbage Patch could be up to 16 times bigger than previously estimated. The new model, published in the journal Science Reports, is based on data from both sea and air surveys. It predicts that the gyre of human debris floating in the North Pacific Ocean contains between 45 and 129,000 tons of plastic, floating in an area of the ocean covering an estimated 1.6 million square kilometres. Even the most conservative estimates of this giant vortex of trash quadruples the amount of plastic in the patch, with around half made up of deadly fishing nets. Microplastics accounted for less than 10% of the total mass, but 94% of the estimated 1.8 trillion pieces of floating debris in the area, which is one of 5 major ocean gyres. The New South Wales state government has begun another major trial of driverless cars on public roads, this time testing models from Tesla, Volvo, Mercedes-Benz, BMW, Audi, Hyundai and Lexus. The trial, which will last 6 months, began just as a pedestrian was struck and killed by a driverless car during a similar test by Uber in Phoenix, Arizona. That was the first fatality involving a fully autonomous vehicle. Uber says it was suspending all North American tests of self-driving vehicles following the incident. Facebook has released a stripped-down version of its social media platform. The new app, known as Facebook Lite, was originally designed for places with lower connectivity, but has now been made available to everyone. With the details, we're joined by Alex Zaharov-Reutt from IT Wire.
This is a lightweight version of Facebook that was first created in 2015, and it was designed to work on phones that were decidedly not the flagship phones with 6 gigabytes of RAM and 64 gigabytes of space and super high resolution screens and the latest processors. These were designed to run on phones that would be sold in third world countries where the phones are, $50 or $100, and the actual software needed to be much more lightweight and much more capable of running, giving you a smooth experience, which is something that the full fat versions of the apps, as it were, certainly wouldn't do on a less powerful phone. And what people were doing in first world countries were saying, well, hey, we want this benefit as well because we don't want to have the full version of Facebook chewing up all our resources. So people were side-loading the app. So in the end, Facebook has relented, and they've now rolled out an official version of the Facebook Lite app in the US, UK, France, Germany, and of course also Australia. The app is less than 1 megabyte in size. This compares with the traditional Facebook app, which is over 40 megabytes in size. And so this just allows people to have access to the major features that the full app has. So things like the news feed, status updates, photos, notifications. You can still upload things, but it just has much less of an impact on your phone. And that probably also means things like chewing up less battery life.
That's Alex Zaharov-Reutt from IT Wire. You're listening to Space Time. I'm Stuart Gary, and that's the show for now. You can subscribe and download Space Time as a free twice-weekly podcast through Apple Podcast iTunes, Stitcher, Bytes.com, Pocket Casts, SoundCloud, YouTube, Audio Boom, from spacetimewithstuartgary.com, or from your favorite podcast download provider. Spacetime's also broadcast coast to coast across the United States on Science 360 Radio by the National Science Foundation in Washington, D.C., and available around the world on TuneIn Radio. If you want more Spacetime, check out our blog where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us on Twitter through @StuartGary, at Spacetime with Stuart Gary on Instagram, and on Facebook, just go to www.facebook.com/Spacetime with Stuart Gary. Spacetime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to Spacetime with Stuart Gary. This has been another quality podcast production from Bytes.com.